Hey, I'm going to give you a demonstration of the router that I built and all the software and everything that goes with it. So here's the router to start with here. A little over 4 by 8 feet, depending on if you add the curtains, it's quite a bit more than 4 by 8 feet. Here's a linear rail driven by steppers that pull themselves through size 40 chain. The carriages here were made by myself, of course. The other side has the exact same, of course, opposite assembly with the same system of guide rails, the same steppers, same setup. The motors are hooked in parallel to make sure that they stay in the same position. Here's the x-axis, a slightly different but functionally the same guide rail, consisting of rollers that roll on this piece of 1/4-inch round stock here. Same setup of a stepper pulling itself through size 40 chain. The wires are suspended through conduit to make sure that they don't bunch up or get pulled too tight. Works very well. I've never had an issue with it. Off the software. Oh, actually, I should finish showing you the electronics. With the blue light there, that receives USB from the computer. That is basically, it takes that signal and turns it into a parallel signal, which goes to this board. This is called a breakout board. This puts out the signals that we need for the machine, which are these 3 boxes here. They take a signal in and produce controlling power for the motors that is just basically based on the signal. A lot more power than the signal device could put out. I'm set up for 4 axes, although I'm only utilizing 3 of the 4 boards right now. So I could theoretically put a turntable or a print feed on it if I wanted to. Yeah, so that's the electronics. Software. And I will attempt to hold the camera as steady as possible. This is Google SketchUp. This is a file that was it was designed to hold the first bill that we made here, the first dollar bill that we made here in our business. I basically took an image of the state of Wisconsin from a Google search, placed it down, and then got really close in and outlined it 1 line at a time. It took about 15 minutes or so to do that. Once I did that, I copied the image and shrunk it a little bit to give us this. It's, I think, close to, no, I can measure this actually, how wide the path is that the bit follows. Okay, it's a little over 1/8 inch, so it requires a small bit to do that. We take this whole image, we select it, hit plugins, hit export STL file. That's a stereolithography file. It's an industry standard file type for machining things. We'd select inches because the router is designed to run on inches currently, and I've already done this all, so I'm going to leave it. But Meshcam takes that file, that STL file, opens it, and gives us a platform for making our G-code from, so the toolpaths. We've got a lot of options, anything from defining the stock, whether it's the size or not, whether you want to modify it from the size of the image that you imported. You can add supports, you can do the retract height, you can set the retract height so it doesn't hit the piece as it moves. You can program the 0 anywhere you want. You can set a max cut depth if you want to do the system in multiple passes or different layers. You can set the machining region to any portion of the item that you're machining that you want to, and then here's generate toolpath, and we'll spend just a minute in here. Yeah, I have it set up already for some fairly fine-tuned machining with an 1/8 inch ball mill. Depth per pass would be set to 0.1 inches, so a very fine, slow cut. Step over 0.1 inches, same thing. And the feed rate and plunge rate, I usually both leave at 100, although I will turn the feed rate up occasionally to 200 or slightly more. we don't want to do any 3D roughing because that would dynamically use the Z-axis with the X and Y. There are situations where you want to use it, but not here. Parallel path, again, this is not the right situation for it. If we had something like a picture frame, a parallel path machining process would do it quicker, but this isn't a picture frame. It's got a more detailed border. For finishing passes, this kind of does what the 3D roughing does, where it will dynamically go X, Y, and Z axis and contour the entire cut and remove any steps that you've got in it. So in this case, I had step over set to 0.1, feed rate and plunge rate both to 100, and I was using a roughly quarter-inch bit for this. It's a nice feature to have. I don't always use it. I won't in this case, but it's something I have used in the past. So I've already created this file. It's all set. So here is the final program, Mach 3. This takes the tool pass, the G code, and runs it. So I will run it in the air for you for a second, just to show you how the router and the software work together. And then we will run the actual object later. So here you go. And I apologize if I'm missing the screen a little bit. I don't actually have a view screen on this particular camera. It's a GoPro, so yep. So as you can see, it's just contouring the bottom of the object at the moment. It usually starts in the bottom left corner and works its way up to the top right. So alright, I'm going to hit stop and re-zero it in preparation for actually running the object. So you can see the machine actually run. We'll leave that as our 0 right there. We're going to zero everything out. Pick it up and move it back so I can get to it more easily. Okay. And I'm going to place the camera on it and let her run. So here we go. Hopefully I won't lose my camera. Alright, and we are set to go. I'm going to return it to its predefined 0, rewind the G code. And start the router. So, this is it. And again, I have to stress that this router is fairly small. It's rated at a maximum of like 5 amps, I think. And the bits are fairly dull, so we're going to keep the speed down a little bit in this case. It would probably rip through ½ inch at a time if the router were fast enough and the bits weren't dull. That's just what I have at the moment. So, here we go.